Hey everyone, and welcome to another episode of Pathfinder presented by Payload, the leading digital media company in the space industry. I'm your host, Mo Islam, and today's guest is Clay Mowry, Chief Revenue Officer of Voyager Space. Clay has worked for over 25 years in the commercial launch and satellite sectors. He joined Voyager as Chief Revenue Officer back last year, early 2022. He previously served for 5 years as the VP of Global Sales at Blue Origin, and before that, worked for 15 years as President and Chairman of Arianespace. There's so much that we go through today, and so much to discuss, so I'm going to jump right into it, but first, a word from our sponsors. SpiderOak's Orbit Secure software is designed for hybrid space operators struggling to manage the chaos of securing data flow and access to and from tens of thousands of small satellites in low Earth orbit. Using a unique combination of end-to-end zero-trust encryption and blockchain distributed ledger, Orbit Secure allows your mission to orchestrate and secure Earth-to-orbit, orbit-to-Earth transmission, communication, and storage of sensitive data across even the most complex and unsecure hybrid space environments. To learn how Orbit Secure can bring zero-trust security and resiliency to your zero-gravity environments, check out SpiderOak at www.spideroak.com.
Clay, welcome to the show.
Hey, Mo. Glad to be here.
So I need to give you some serious credit. So January 2021, Ari and I reached out to you asking for a call. And at the time, you're leading global sales at Blue Origin, and you agreed to the call, really not knowing who we are and why we're reaching out. But you decide to take the time. You hear us out. We pitch Payload. At the time, I think maybe we had 500 subscribers. But most importantly, you took us really seriously, and you offered to help. And fast forward to today, and I certainly now know how busy you are. At the time, maybe I didn't. But we are super appreciative of the early help that you provided. You're definitely on a very short list of folks that helped us out in the early days. So thank you for that. I did want to just say that.
Hey, that was my pleasure. I'm super happy to see the growth of Payload and what you guys have done with it. I read it every morning and love it. And you guys are doing a great job. So keep it up.
Yeah, well, I certainly appreciate that. So let's get into your background a little bit, because you've had a very storied career in space. You've worked at Ariane, at Blue, now at Voyager, but maybe let's just start from the beginning. Like, what really drove your interest in working in the space industry, and what was your career arc?
Well, I got into space by accident, actually. I started at the U.S. Department of Commerce, which is where everybody starts in space, right? That's where you start off, the Commerce Department. I literally got a job in the Office of Aerospace, and they gave me the space portfolio. And this is post dissolution of the Soviet Union. And one of the objectives at that point was trying to find ways to bring Russia into the West, right? And so there was a set of launch negotiations that were taking place with the newly formed Russian space agency, Roscosmos. And so literally, I think 3 months into the job, they sent me to Moscow as part of a U.S. team to start working on those negotiations with the Russians. And so it was a really interesting time, right? I was in my 20s, and it was fascinating to be in what was, for me, the former Soviet Union, like standing in a rocket factory in the Khrunichev facility. So that's how I kind of got hooked in it. It was astounding to me that was the turn of events. And by the way, now I think almost 25, 30 years later, we've seen the downturn, right? What can happen with the conflict in Ukraine? But it was a great way to get started in the business. From there, I ended up getting a call from a friend of mine who said, we're starting to form the Satellite Industry Association. There's a group of us want to start a trade association for the commercial satellite industry. Would you be interested in helping us set this thing up and running the organization? So it was a one resume job search. I ended up going over and interviewing for the job, so helped found SIA, got to pick out the logo and the colors and build that thing from scratch, which was great. Got to meet all the senior leaders in the satellite communications industry and launch industry and ground equipment industry. So it was a super job for me to get to really know all the players in the business. And then I guess from there, a friend of mine, Doug Hayden, who had been running the U.S. subsidiary for Arianespace, called me up and said, "Hey, I'm going to retire in a year or two. Would you be interested in interviewing for my job running the U.S. subsidiary for Arianespace?" And he was a dear friend of mine. He had been on my board at SIA. And I thought, wow, this is like one of the greatest jobs ever. I would get to work for a European rocket launch company, go to rocket launches, work with all the satellite customers. And it was a tremendous job for me for 15 years. ran Arianespace's Washington office. So really neat.
At the time, give us a little flavor of like what the commercial space industry was like at the time, right? Like how many?
It was so I've seen in the course of my career arc, the industry has really evolved tremendously. Right, we went from a place where it was communication satellites, and when I say communication satellites, I mean geo communication satellites were 95% of what you would call commercial space, right? And so these were big satellite operators. Intelsat at the time was actually still, an international treaty-based organization, right? And ComSat was the U.S. signatory to it. SES in Europe, in Luxembourg, Eutelsat in Paris. These were kind of the huge players in the comms field, and everything revolved around them, and transponder pricing in their regions, and everything that went to support that, from launch to ground equipment to all the pieces of that equation. And then direct-to-home broadcast satellites, so DirecTV, Dish Network, back at the time, Alpha Star and B-Sky B from Rupert Murdoch and Prime Star from the cable guys. That was all just starting to happen, and it was a revolution, right? That was the commercial space revolution back then. Was actually bringing satellite technology to consumers. Instead of the big giant C-band antenna in their backyard, now they had these little pizza pan dishes outside your house, and it became the fastest selling consumer product of all time, and revenue from the industry just exploded because now we were down to the consumer level. So that was fun to see that transition. But where we are now, I mean, this is the funnest time ever in space. And this is just, I'm like a kid again, seeing all the investment, all the opportunities, reusable rockets, huge driver for that, lowering the cost to access to space. But all the activity now where you have commercial actors that are some of the largest, if not the largest. I always ask this question when I speak now: who is the largest commercial space, largest space player in the world right now? And it's SpaceX for sure. More launches, more satellites. They're doing all of it. So it's amazing to watch.
So what prompted the move from Ariane to Blue, right? So now you're, Blue at the time. Well, actually, I don't want to speak for you, so maybe you tell us.
So, Blue had been super secretive for over 10 years, and kind of people inside the industry knew something was going on in West Texas and up in Seattle, but nobody was quite sure what, because there was no sign on the outside of the building. Nobody really knew who worked there. People knew Jeff Bezos was doing something, but really the only information you could get from it is looking at like kind of public filings. And there were some journalists that were sniffing out some things that he was doing. I knew Patty Gray Smith, who the Patty Gray Smith Fellowship is named after. She was former head of Department of Transportation, FAA, Office of Commercial Space. She had left that job and was consulting to them. And so she was kind of hinting to me that there was cool stuff going on there. Another friend of mine, Brett Alexander, was working for him. And they asked me if I'd be willing to talk to people at Blue. And so I had a lunch with Rob Meyerson, who was the president of Blue. I flew out to Seattle. I met them. And it was about 500 people at that point, Blue Origin. And New Shepard was just starting to fly. So that was pretty cool. And they were putting videos out on that. So that was pretty neat. You could see that they had done something with a kind of small and mighty band of engineers to launch and then actually land a booster. So that was their calling card. And I went out to the factory in Kent, walked the floor, met with their team, and it was super exciting to me, right? That was just like a really neat thing to watch them trying to make reusable launch systems. And I was a launch guy at heart, right? I'd been 15 years doing the launch thing. It was one of those things where you kind of got to decide, right? Like, this is the opportunity of a lifetime. So it was really neat for me to go work for Blue and build their. Rob always jokes with me that I like sent him like a manifesto when I started. Like, here's all the stuff I want to do. What can we do? How do we approach the markets? And let's go. And so I think that helped me get hired there.
I love that. Was there any like single person or group of people at Blue that really helped you ultimately make that decision, or was the factory tour enough to know that there was something big going on?
Well, there was a few folks. Ariane Cornell was there, and she was the former head of SGAC, Space Generation Advisory Council, who I'd known for several years. I was on her board of advisors. I always tell this story about how I feel like, I was hoping to recruit her when I was at Arianespace to come and work for the company. And in fact, she recruited me to come to Blue. And she now has my old job at Blue. So it's an interesting, I think it's like a judo move, right? Where you use your opponent's way to get you. But Ariane was I think we had a cookout on the roof of her building in Seattle, downtown, beautiful summer day. Seattle in the summertime is the most glorious place on earth. You're looking at snow-capped mountains and the ocean, and it's just spectacular. And so she and Sam Gunderson, who's now back at Johnson Space Center, Brett Alexander, a couple other colleagues there, putting the hard sell on me to come to Blue. And so it was an incredible experience for me. Tremendous opportunity. We got to sell New Glenn, enter it into the marketplace. And then before I left, I got to work on all the New Shepard astronaut missions. And so leading all the sales activities for that. And so that was super fun to run the auction, set an anchor price, and then, sell the early seats. I think we sold over $100 million worth of capability there in just a couple of months. So that was a really neat thing to see. And then to watch those astronauts fly, for those early missions. And I got to train as an astronaut. It was really neat. And one of the guys I sold a seat to, my team sold a seat to, was named Dylan Taylor, who flew and who's now my boss. So, one thing leads to another.
There you go. All right. Well, we're going to get to that in just a second. I actually do have one question on the auction, because now that you bring it up. So what was the first auction price? I don't remember exactly, but I remember many millions.
So the idea was really, and this is, when I tell this story, I'm kind of astounded because I'm a bit of a student of economics. I took economics; it was my minor in undergrad, and then I got an MBA. And so I'm always fascinated about economics and how things work. And I was familiar with auction theory, right, which is a whole school of thought and academic thought that the FCC, the Federal Communications Commission, used quite deftly in auctioning spectrum, right, for communication satellites, other activities, all the cell phone spectrum that's out there. They've auctioned all this stuff and made billions and billions of dollars for the U.S. Treasury. And a woman who used to live, she was my backyard neighbor just across this behind my house, across the street. A woman named Margie Weiner, and I always joke that she should have been the highest paid federal employee ever, because she was the one who ran the auction process at the FCC. She was in charge of auctions at the FCC. And auctions, like I say, it's an amazing way if you have a scarce resource or a limited finite resource and you want to get the most value for that you create an auction where people are kind of lining up to bid on something that's scarce. And so the question was, how do we enter into the market, right, without just picking a price out of thin air? And how do we enter that market anchored high and then work our way down the curve into something more affordable? Because when things debut, there's always a lot of excitement around them. People are willing to pay more. You want to get a return on that invested capital and then get the right price, right, for what the marketplace could bear. And so there were a couple guys at Blue that came up with this idea of doing an auction. And so it was really neat to watch it come to life, put in place, to do the auction itself. And I can tell you, we were all quite pleasantly surprised and happy that somebody was willing to pay $28 million for the first flight to fly with Jeff.
Yeah, so $28 million is a big number. What was did that just like completely blow away expectations? Was that even in the ballpark of any of the highest guess?
It was. I'll say we were running a little bit of a pool inside, and nobody was close to that number.
Yeah, I can only imagine. I actually remember watching it live and just be completely like blown away. But yeah, that was obviously an amazing feat. So you're now the chief revenue officer of a company called Voyager. Maybe tell us a little bit about what does Voyager do, and what ultimately made you decide to join the company.
Sure. Voyager is a really interesting company. It's about 5 years old now. In the last roughly 4 years, we've acquired 7 different companies, small space companies with interesting technologies, and these include things like satellite communications subsystems, software-defined radios, star trackers. This is a company called Space Micro out in California. Propulsion technology. So we have throttle solid rocket propulsion technology, which I didn't even know you could do before I got here. I was like, that's impossible. And then they showed me that they can do it. They also do airborne ISR technology for defense. engineering, design, and integration capabilities. That's Zinn, a company we acquired in Ohio. Does a lot of that work, as does NanoRacks. We do launch. We launch a lot of small payloads from the ISS and other platforms. We do a lot of payload and mission management, advanced interface technologies like electro-permanent non-mechanical docking systems, Altius space machines. We do coatings and things like that. Pioneer. I talk about it like a space chemistry company. Really fascinating, the stuff that they've developed on the chemistry side. Airlocks. We have the Bishop airlock that's flying on board the ISS right now. Did a trash run with it, but you can use it to deploy satellites and has external positions. So really interesting. But probably the most exciting thing we're working on is Starlab, which is a commercial space station, which would be the follow-on to the ISS when it's decommissioned around the end of the decade. So we're really excited about putting together, and we got the largest of 3 awards under the Commercial LEO Destinations program for NASA to put that together. So that's been a good chunk of my time has been working on that as well.
So a couple initial questions. So on Voyager, just taking a step back, what you're describing. It sounds like it's almost like a holding company of sorts.
That was the model as we started. It was a holding company model. Now we're focused on becoming more of an operating company, and so we're focused on 3 segments: exploration, so kind of civil space and exploration capabilities, technology, which can be across different customer segments, but some of the satellite and docking technologies I mentioned, some of the coding and other technologies, and then on the national security side, defense, which is a lot of propulsion, but it's also some other stuff that I can't talk about too much. But
sure. Maybe you can talk a little bit about Dylan Taylor, right? So he's one of the early customers of New Shepard, New Glenn, but he's been in the industry for a while. So tell us what I think would be most relevant for folks to know about Dylan. Why did he start Voyager? Any insight there would be interesting.
He started it with a guy named Matt Kuda, Matt was a fighter pilot, U.S. Air Force Academy grad. And the 2 of them were excited about space, wanted to get into this industry, wanted to make a difference, and really wanted to build infrastructure that was going to grow the new space economy, right? That was kind of their vision. And Dylan is an amazing guy to work for, super high energy, thought leader. He's a runner, athlete. Keeping up with him is something. But I love working with the guy. It's infectious, right? His enthusiasm for the space business. He flew on New Shepard. He climbed Kilimanjaro last year. I mean, he's got this adventure spirit, I think, in him. And he loves space and what space can do. He's also a philanthropist, so he has Space for Humanity, where he felt strongly when he flew that he wanted to enable other folks that couldn't afford it. Right? He's done well in his career and could afford to buy a ticket on New Shepard, but he wanted to try to figure out a way to get people to space who couldn't afford it, and so he to basically pay it forward kind of thing. And so he's established that, and now has flown some folks to space on New Shepard, and kudos to him for thinking about it that way. That having that overview effect, to go above the carbon line, look down on the planet, and get people who don't have the means to do it. That's important. So, it's really great working with him and the vision that he and Matt Kuda have for the company.
Right. Can you, just to keep in theme, can you share a little bit about who was it at Voyager that convinced you to come over?
So it's mostly Dylan, but I knew Eric Stallmer is an old friend of mine. If anybody knows Eric, he's really a consummate professional here in Washington, D.C., ran the Commercial Spaceflight Federation before he came to Voyager. I met him a long time ago when I was running the Satellite Industry Association. He was running the Space Transportation Association, and working launch, and I was working satellite. And as it turned out, he came over to meet me for lunch. And as the story's told, he saw a poster on my wall from Albany, New York, and asked me if I was from Albany. I said, yeah, I'm from Albany. He said, well, I'm kind of from Albany. And then we said, well, we're really from Schenectady. And so I'm kind of from Schenectady. Well, really, I'm from Niskayuna. Well, I'm from Niskayuna. So it turns out we grew up in the same hometown. So we're a fast friend from there. And Eric, Dylan had brought in Eric to lead the government relations and government affairs team here. And so Eric was also instrumental in convincing me to come over. And I've been friends with the guy for 20-something years. Never worked in the same company or office with him. And so now the problem is that whenever we're together, it's kind of hard to get work done because we're always talking old stories and riffing. And but he's a great guy, and I love Eric.
Yeah. Well, let's you mentioned Starlab, so let's talk a little bit more about that. So, I think one of the things that I get a lot, right, whether it's talking to investors or just folks who are new to the industry, especially when it comes, it's just like, hey, what are some of the exciting parts of the industry that I should pay attention to? And one of the areas I typically talk about is space, infrastructure in space, right? Orbiting infrastructure in space, having a platform for humans to be up in space and be doing research and manufacturing, and there's congressional directives to sustain human presence in low Earth orbit, and there's a lot of things to point to for why we should be up there and the importance of being up there from a science and exploration perspective. But typically the next question is, well, what's the business case, right? Understand why governments need to be doing this. Understand why governmental agencies and why the ISS was arguably one of the largest scientific collaborations, international scientific collaborations in the world. But why get commercial players involved, right? So from your perspective, right, what is the business case behind Starlab?
Sure. Let me start at the beginning, which is we'll go to space to benefit life on Earth, right? Like that's the goal. And we need to learn how to have a continuous human presence in space. We need to learn how to live and work in space. And we need to learn how to basically build a space economic system, right, that functions. And to do all that, we need space stations, right? We need to go back to the moon. Absolutely. Artemis is cool. When we want to go to Mars, we want to go become a multi-planet species. But those are longer term goals. And in the near term, having space station, plural, right, with another S, space stations up there and operating is super important to the work we're doing. And remember back that I think the ISS has been up there for about 23 years, something like that, continuous operations in space. So it was not designed originally, right, as this giant functioning laboratory. And now they've made it into a laboratory, but it's been up there for a while. And if you think about the timing of that, knowing that it probably took about 10 years to engineer the technologies and then put the thing in orbit in pieces. And so you're talking about 30-year-old technology, right? So it's now time for a refresh, reboot, Space Station 2.0, whatever you want to call it. We need to, or maybe it's 3.0 if you say Skylab was the first one, right, that we did, launched on a Saturn. So we need to be up there and do this work. And we want to focus, I think, primarily to start on the space agency customers that are out there around the world, NASA, ESA, JAXA, the international partners, allied nations that want to do work in space. And we want to design a laboratory and habitat that's world-class, that's geared for research, that allows us to do a lot of great science and advance technology in space. So that's really our goal with Starlab. We have a huge amount of volume that we're talking about. Our premise starts with a single launch. So we actually launch this thing as a stack. We're going to take advantage of large, super heavy lift launch capability that's out in the marketplace, where you can launch a huge stack in one spot. And much like, if you want to actually think about it like Skylab, it's kind of like that, right? Launched in one giant stack where we have a power propulsion element, an equipment bay with docking ports, and then a big laboratory and habitat on top. And so roughly 7-8 meters in diameter on top that will have 40% of the volume that flies today on the ISS and 100% of the research capability of the ISS today. So save a lot of money by getting it launched in one shot, which is a unique feature for us. We're working with Hilton Worldwide Hotels and Resorts to design the interior of it. Everybody's like, oh, space hotel. Yeah, we're going to get to the space hotel piece. But to start, let's just talk about the astronaut experience for the customers, right? How do we create a space that's comfortable for living and working? And when you have a huge diameter of an amount of volume, you can do different things than what we do now on the space station. And so Hilton has a ton of technology and expertise. You guys, everybody stays in Hilton Hotels and Resorts. I think they have over 1 million hotel rooms, 17 different brands on here on the ground and people stay in, from DoubleTree to Conrad to Hilton's. So these guys look at things like antimicrobial materials, sleeping, the smells, the cuisine, the food, like everything that goes into, keeping your stay and having it be invigorating and fresh and getting a good night's sleep and all these things. We want to bring that into space and working with Hilton. So we've had some great interchanges. They were at our systems requirements review in NASA in June. We took them down to Johnson Space Center with us, and so they're a great partner as well. So we want to make this a much better experience in space. We want to put the kind of capabilities on board Starlab to be able to do biopharma, to do manufacturing space, do these other things. So I think that, our premise is start from there and then grow into things like tourism and commercial astronaut missions. We want to empower smaller countries and agencies that haven't gone to space to get into space. And so there's a lot there to do, but we see it as a step-by-step progression, right, along that line. And the primary focus to start is space agencies and the research that they do, that's government, a lot of it's government sponsored, some of it's commercially sponsored, and really building a world-class, basically science park in space, right, that we can do that work on.
Yeah. So if I hear you on this, it sounds like the near term kind of low hanging fruit is just, as the ISS decommissions naturally over time, that just pulling in some of that, quote unquote revenue stream, right, of agencies doing science and research, what they do on the ISS already today, and just shifting that over to Starlab, right, on day one, and then over time.
Absolutely the plan. So what's great about Voyager and our approach to this, we have NanoRacks, which has flown more payloads on the ISS than any other company in the world, more commercial missions, right, than any other country. We've launched satellites. We have the Bishop Airlock on there. So we have all this experience actually doing science and payloads for customers all around the world. And so we can do that now, right up until the ISS is decommissioned, and then we can migrate a lot of that work onto the Starlab platform, and hopefully with a much easier user interface. I mean, we're going to try to take advantage of the broadband constellations like Starlink and Kuiper that get launched, or some of the other ones, GEO and MEO systems are out there. We haven't decided yet, but we think there's a plethora of communications options that will allow people to manage payloads and us to get data up and down. You think about things like edge computing and AI. Gosh, the stuff we can do now that we could build in to a space station platform is extraordinary in terms of the data and the ability to actually work with data and manipulate experiments and research projects in space. So if you leverage the new technology, and by the way, we're about 5-6 years from getting this thing up. We're going to have it up before the ISS is decommissioned. Think about all the things just in the last couple of years with AI, right, that nobody was thinking about now, things that we'll be able to do when we employ this thing and put it into orbit. So we're very excited about that future, but we don't want to, get too far out over our skis with some of the storylines here. We're going to start with what we know. Our research markets that are proven, and then build on those. But if we can build in capability into the system and take advantage of these technology revolutions, I think we're gonna find a great market for it.
Why was it important to partner with Airbus here?
Yeah, so Airbus came to us, it was over a year ago, and they had been working on a concept called SciHab for the European Space Agency. So Europe wants to play a role. They want a human spaceflight program. They fly, obviously, ESA astronauts to the ISS with great fanfare when these guys come back. Alexander Gerst in Germany, or Thomas Pesquet from France, or Tim Peake, or Christine. I mean, like, these people are superstars when they get back on Earth, right? Like, so they see the value in the mission sets, the payloads, the science that they're able to do up there. And so for us, it's super important to bring Europe in as a partner into Starlab, right? Because we have the ISS today. There's an intergovernmental agreement that exists, right? So ESA is partnered with NASA. They have the Columbus module in orbit, just as JAXA does, or the Canadian Robotic Arm. So we have an international partnership. How do we recreate that commercially, right? Instead of space agencies, this is a commercial space station. How do we bring them in? And so they had this SciHab concept. They came to us and said, hey, could we do something with Starlab? This is really an interesting prospect. And so we started talking to them. And the more we talked to them, the more we loved what they were doing and what they had designed. We brought them in to start, and we announced in January of this year that they were providing us with engineering services, support, technology. And the more we worked with them, we said, we really need to stand up a joint venture to make this thing real. And so we were happy to announce this past month a joint venture with Airbus, where they're going to be investing in it along with Voyager. Obviously, it'll be U.S.-led, U.S. Majority owned, all those things that we need to do, and to be under contract with NASA. But what it gives us is a really nice avenue into European markets and European space agencies and European Space Agency itself, ESA. So those agencies, right? I mean, you think about it, they don't just want to write a check to America, right? They want to have jobs. They want to have technology development programs that they can hang their hat on and show the taxpayers in Europe that they're investing in this stuff and getting a return on it. And so this gives them that avenue, gives them a stake in a space station that's flying. And so that's super important. And we're really excited to have them. They're a great partner for us. Obviously, it's Airbus. They know how to build stuff and fly stuff. They got amazing heritage. And so it's really wonderful to be working with them. And, stay tuned to this channel. We'll figure out some other partners we'll bring in.
I'm on the edge of my seat. Hey, you're welcome to tell us now if you want.
I'm going to hold off.
We'll hold on.
I'm going to hold on.
We'll hold up, but I do want to actually talk about cost structure in just a second, but we're going to take a quick break, and we will be right back, so stay with us.
Space is the new frontier for cybersecurity. To quote the commander of the U.S. Space Force's Operations Command, cyber threats are unfortunately the soft underbelly of our global space networks. SpiderOak, the leader in space cybersecurity software, is dedicated to providing space operators with the solutions they need to protect hybrid space systems. Their Orbit Secure software uses a unique combination of end-to-end zero-trust encryption and blockchain distributed ledger, allowing missions to orchestrate and secure Earth-to-orbit, orbit-to-Earth transmission, communication, and storage of sensitive data across even the most complex and unsecure LEO and hybrid space systems. To learn how Orbit Secure can bring zero-trust security and resiliency to your zero-gravity environments, check out SpiderOak at www.spideroak.com.
Hi, welcome back. So I want to, last we left off, we were going to talk about cost. And, let's maybe just start off with the ISS, right? The ISS costs $100 billion to build. If you include the cost of the shuttle, 150 billion, right? That's obviously not what Starlab's going to cost, right? But so tell us a little bit about why it's now starting to make sense commercially to build something like this, which was historically such a massive CapEx endeavor.
Sure. And what we're talking about here, I'm not going to give you an exact number, but it's a tiny fraction of what that $100 billion is. So, and why do I say that? So a couple of things. One is the price of access to space has come down considerably over the last 10 years. And I've written a couple papers on this when I was at Arianespace in Blue and authored some journal articles on it. And you can use different metrics to look at the price per kilogram. But what we're doing now is taking advantage of these very, very large rockets. We're taking advantage of reusable rockets for crew and cargo capability. But even with some of the expendable vehicles, the prices come down considerably. And so that's one piece of it. A single launch space station is a second piece of it, right? That we're going to save, depending on what your metric you're comparing it to. But let's say a space station that would take 3 or 4 launches to get in orbit, right? If you do it in a single launch, you're saving $500 million easy on the launch piece alone. As opposed, I can't remember how many, I should know this off the top of my head. How many shuttle missions did it take to put the ISS together? Dozens, I'm sure.
Yeah. I'm not sure what the exact number is, but it's got to be something like that.
Yeah. So we're trying to do something that's fully integrated on the ground. We got the whole thing set up. We stack it in a very large, super heavy rocket. We put it into space, and it's ready to go. And then we can access that. And even the cargo resupply and crew systems are really, those numbers are coming down as well. I was in India a couple of months ago, and we announced in July an agreement with the Indian Space Research Organization to work with them on their Gaganyaan system, which is a capsule kind of similar in size to a Dragon or a Soyuz that they're developing for, first for cargo and then for crew, that we would love to be able to utilize as well. And so actually open up having India, right, being able to be a human spacefaring country. Congratulations, by the way, to them for having just landed on the moon and have a rover now on the moon. It's incredible. Super amazing accomplishment for a country whose space budget is like 1/20th of NASA, and they're able. Yeah.
Have you seen all those there's a bunch of these like memes going around social media about how they spent like less than the cost of the Interstellar movie to produce, right?
I have not seen that, but it does surprise me.
But there's a bunch of these like comparing the cost versus like other things, and it puts it into like perspective, and you're like, holy shit.
Chairman Sumanoff, who heads ISRO, is a friend of mine. I served with him on the IF Bureau, and he's basically the father of the GSLV Mark III rocket, and he's an amazing guy. And when you go over there, you see how proud they are, right, of their accomplishments in their program, and they should be. They rightly should be proud of what they've been able to do on really kind of a shoestring budget. It's really amazing what they've done. And people always say to me, oh, ISRO and India, whatever. I said, do you realize when I was at Arianespace, they were our single largest customer in the world? People said, what do you mean? I said, Arianespace launched more of their satellites for communications over in India than any customer in the world. I mean, every year we had another ISRO satellite to go up into space to provide comm services in India. They're tremendously successful. And so anyways, but that's just an example of if you can leverage a low cost capability, right? And by the way, the other thing is these super heavy rockets engender, which is, it used to be as a launch guy, right? So launch guys like myself, I still think of myself as a launch guy. Even now, I'm more of a space station and infrastructure guy. Launch guys think in terms of mass, right? We think about how heavy is it? How many kilograms? What's the orbit? What's the delta V? How much energy is going to take me to get from here to there? Satellite guys thinks in terms of power, irradiated power, right? How much EIRP, how much irradiated power can I drop on whatever it is so that the antenna size can be small, right? And that we can close the link budget. So now you've got this thing where SpaceX, I think, and Blue Origin is going to be in this space soon with these big rockets, with New Glenn and with Starship, where mass to LEO is not really the driver at all, right? I mean, these are rockets that can deliver somewhere between 40 and 100, maybe even more than 100 metric tons to low Earth orbit. This is incredible, right? What they're able to achieve. And I learned this lesson when I was at Blue. I knew it from Arianespace, but it really, here's how I tell the story. When I was at Arianespace and we went from Ariane 4 to Ariane 5, we went from a 4.2 meter payload fairing, right, the nose cone of the rocket, to a 5 meter fairing. And everybody said to us, 5 meter fairing. Nobody's going to build satellites that fit in a 5 meter fairing because all the other rockets had a 4 meter fairing, right? So nobody wants to build a larger satellite that you're the only launch guy that could put it into orbit, right? So we were told this repeatedly, like it's never going to work, 5 meter fairing, because Proton and the other vehicles, Atlas and the other vehicles that are in the market. And of course, as soon as we built it, people started building bigger satellites that would fit in the fairing, right? Because they wanted more power, they wanted more capability in the satellite. And where it really came home to me was when we were building New Glenn. And when I got there, and the first renderings of New Glenn, if you see it, has a 5 meter fairing, right? Even though the vehicle is about 8 meters in diameter, right? And so I asked the engineers, well, why are we doing this? And I got the same feedback, which was, well, everybody else flies a 5 meter fairing, so we would start there, and then ultimately over time we would grow. So I remember going to the management and talking to all the leaders in the company and going, I know this might cost a little more because we already started designing the payload fairing. By the way, they built several payload fairings from New Glenn already down in Florida. It's one of the first things that they did. I said, can we really look at building to the full diameter of the vehicle? And we wrote a memo and we did it and we got it approved. And where it really came home, Mo, to hit me was when we were talking to the Constellation guys. So Kuiper and Lightspeed, which is Telesat's venture, OneWeb, or the other guys that are in the marketplace that are looking to launch constellations to satellites. And volume is their driver, right? How many satellites can they stuff into a payload fairing to complete that orbital plane? And it really becomes a driver when you talk about these mega constellations, right? It becomes such a bigger deal for them because it's so much more efficient on the launch piece. The more satellites, and if you can complete that plane in one launch or two launches, it drives the economy down. The economies for deploying spacecraft goes down by like 40 to 50%. And it's incredible when you think that as an operator. So that's what we're trying to do, is take advantage of that volume in these vehicles with this, 7, 8, 9 meter capability. And, the hook height is something like 16, 17 meters on these vehicles. It's huge. You could put school buses in there. They're massive, massive, massive fairings. Yeah.
So you're alluding to something that I've been thinking about for quite some time, and I believe in, which is that vehicles like Starship and New Glenn are going to dramatically change mass and design constraints for the industry, and
Exactly.
people are just going to build differently. And the question I have for you is, like, do you think the industry is ready, or folks are like? I mean, I actually appreciate the fact that this is a way of thinking that Voyager is already clearly like leveraging and leaning into. But do you feel like the industry kind of knows what's coming? Like that we're going to be able to have this massive, and then all of a sudden you don't need to buy the super expensive solar panel. You can get away with buying the terrestrial solar panel because yes, it's thicker, but you can fly it because you don't have to worry about those types of constraints anymore.
Yeah, so the answer is yes. And I actually had that, in my last 2 jobs, I've had this discussion with people who build antenna, like exactly what you're talking about. Like how would we just build a much simpler, instead of one of these unfurlable, sorry, Viasat, not throwing shade, but, like instead of some crazy unfurlable antenna, you have a clamshell antenna that just deploys and boom. And in fact, when I was at Blue, we did a study with Harris on that topic to actually look at what a much simpler clamshell kind of antenna that could deploy would look like. And it takes a lot of technical risk and complication and cost out of the equation, that you can get very large antennas inside of these structures. That's just one example but to your point, I think smart people are thinking about this. It is a little bit for somebody like myself who's been in this for over 25 years. When you think about space, and we always think about designing, and this is the same thing, by the way, when you think about stainless steel structures versus inflatable structures. So if you're going to Mars, inflatables make a heck of a lot of sense, right? Because it's a lot of energy, it's a long transit time, you need a lot of propulsion capability to get you to Mars. So weight, mass matters, right? Like the mass of your system matters, and so inflatables are so much more lightweight. They make a lot of sense for that kind of application, or for even for the moon. But when you're going to LEO, stainless steel is just great, right? Like it's simple, it's a lot easier to manufacture, deal with. And so if you take away some of these mass and volume design constraints, what you're talking about, it really allows you to think differently, and it really changes the economics of what we're doing.
Yeah.
So people who are smart are thinking about that. Absolutely. It's as I say, it's blow minding. It's not mind blowing. It's blow minding, because you got to really think about it differently.
I'm going to use that one. So last question on Starlab, and then this one, is about competition, and part of this hits close to home, right? Because Blue Origin is thinking about and working on orbital reef. There's Axiom with Axiom Station. There's Northrop Grumman. They're building their own commercial space station. How do you think about competitive landscape in space station infrastructure? And is there a value to being first? Meaning first to be operational, first to be live and generating revenue?
Yeah, I would say first, it's clear NASA wants competitors in the marketplace, just like they have for resupply and what they're trying to achieve in crew. And so we know that going in that they want at least 2, if not more, one of many. And I think competition is a good thing. I mean, I always think competition is a good thing. And it drives you to be a better provider, more capable, and it makes you move faster, right? If you're a slow moving, bureaucracy of a monopoly, it's no fun. So we expect there to be other competing space stations. People are taking different approaches to it. We think in terms of our design approach, our single launch configuration, our focus on core markets to start, and then progressively growing through that we have a good solution, right? We think we have really probably the most streamlined solution to getting to space and getting operational and doing it in time to take over the capabilities, from the ISS. So that's our goal. And I don't spend a lot of time, to be honest with you, thinking about my competitors night and day. I think about us trying to execute on what we're trying to do now, leverage the capabilities we have, work with the right partners, and get to space and make sure that we're there on time. I think the biggest problem in space is that things always slip to the right. So how do you build something that is doable, achievable, that has really interesting and neat design features that advance state of the art, but are not unobtainium or things that are going to take you 10 years to develop and are outside the box, right? So leverage the technologies that are there, try to take a design philosophy that's straightforward, and then we'll iterate, right, over time. And I'm hoping that the Starlab that we're building to serve these space agency customers is the first of many. We think with our design approach and the launch approach that we could build more than one Starlab, and so I think that's part of our value proposition as well. So that's what we focus on. Good luck to my competitors. We expect others to be in the marketplace, and I think that's a better world, right? It's a better space. Yep. Maybe it's a better out of this world place to be.
Fair enough. So just switching gears for a second, I do want to talk about IAF because you play a big role there, and it's an important organization. So maybe talk a little bit about what is your involvement. Well, actually, what is IAF? Excuse me. What is your involvement, and the work that you're doing over there?
So the IAF is the International Astronautical Federation. It's a Paris-based nonprofit organization. It's been around since the early 50s. And it was formed originally kind of as the Cold War was getting colder, getting hotter. I don't know what happens with the Cold War. When it was at its higher tension point in the 50s, it was a great place to bring together East and West to have dialogues about peaceful use of space and to build trust and relationships, and countries could understand what the others were doing, and it created a forum for people to get together, spacefaring nations to get together and exchange ideas. Now, we are the world's, I say we because I'm now the president. I was elected to a 3-year term in Dubai. So I'm well into my first year here. And now Paris was my first official International Astronautical Congress, which is the world's biggest international space conference that's put on every year. It's kind of like the Space Olympics. Some people call it the Space Olympics because we get people from over 100 countries to come from around the world. And we have an opening ceremony and a closing ceremony and all this stuff that goes with it. So it's a fantastic forum. It's built on a technical program. We have a huge technical program for it. Thousands and thousands of abstracts are submitted. Huge volunteer core that looks at the technical papers. And then we built a kind of a trade show on top of that, right? An exhibition and ability for companies to come together and have a value proposition to meet space agency leaders from all around the world. So right now, we have 476 members from 75 different countries. It's definitely the most international of space organizations. We had 9,600 people came to Paris. We're going to be in Baku, Azerbaijan, in about 6 weeks from now, which is going to be super fun. I went and visited the site. It's absolutely spectacular. The buildings, the venues, and I got to catch the F1 race when I was there. It was super fun. I really had a great time. The year after, we're going to Milan in Italy. And then the year after that, we go to Sydney, Australia. So, and we also just did, in Norway. I was up in Norway earlier this year in the spring. We did our first conference on climate change and how space is involved in climate and in understanding climate change and mitigating the effects of climate change. And so we do regional conferences around the world, and then we do this kind of Space Olympics every year. It's an extraordinary organization. If listeners have not gone or don't know anything about it, it's really an amazing place. I've been doing it for 20 plus years. I was kind of super honored to be elected the president. It's a little bit different to have an American as president, and it's a little bit different to have somebody from industry. I'd say a lot bit different. There's only been, I think, one or two of us in the 70 plus years of the organization. So I'm honored to be in that position. Love my space community there, and it's a great event. And if you want to come and see the international space community, it's the place to come.
Hey, I wanna touch on something you just mentioned, which is you've had a storied career, so it's no surprise to me that you're in that role. But you're kind of alluding a little bit to some cultural changes that have occurred in industry, right? So we could talk about that for hours, but I'm more just curious, like, what are some of the biggest cultural changes you've noticed in your time in the space industry from when you've entered from where it is right now? If you could summarize that in like a minute or two.
So culturally, we're still striving. We got a long way to go, but we're way more diverse than we used to be. Right. And when I say diversity, we talk about 3G diversity at the IAF, which is gender, geography, and generation. But it's more than that. And so, I've been involved and been fortunate to be involved in a lot of the youth movement in space. So a lot of these organizations, as I mentioned, the Space Generation Advisory Council, or is on the board, Future Space Leaders Foundation, which I've helped to found with a couple of friends of mine. At the beginning of the Matthew Isakowitz and the Brooke Owens Fellowship programs, both domestically and internationally, and I've counseled people that want to set up nonprofits in their countries on how to do it and how to go attack those markets to raise money, to create scholarships and opportunities and internships, so that young people can come into the industry, can advance, can get jobs, and thrive and stay in the industry. So that is super important to me, and it's the most valuable thing I do, I think, really.
Yeah. No,
Yeah.
I certainly appreciate that and all the work that you've done for industry, no doubt. All right, last question as we wrap up here. When do you think New Glenn will fly?
Oh boy, that's a tough one. It's funny you mentioned that. I'm just this week. I think I'm going to get it. So I'm potentially. It's interesting now. I used to sell New Glenn, and now I'm a customer for New Glenn. So I'm actually going to get an update from those guys later this week, and I'm going to see them in Paris in a couple weeks from now at World Satellite Business Week. If I look online and I see the picture, because I've been, I'm kind of 2 years removed now from Blue, so they got a tremendous amount of hardware in that factory down in Florida, and they're advancing quite well. I'm hoping they'll fly. Right now next year they're talking about flying next year, and I would love to see that vehicle fly. I hope maybe they'll invite me down now that I'm a customer. Even though I'm not with Blue Origin anymore, I would love to see New Glenn fly. I'm rooting for those guys to succeed. I still have a ton of friends there. A lot of my team that I recruited in there. So I wish those guys well. They're trying to do the right thing and lowering the cost of access to space, opening up space to new markets, and that vehicle is tremendous. The design philosophy around it, safety margins they're building into it. I mean, it's an incredible machine. Different approach than SpaceX. I'll admit to that. It's a different. They kind of have SpaceX takes a little bit more of a fail forward approach. You can see in the Starship development. And New Glenn is a little bit more of the test, verify all the things, test the system, and then fly as you test approach. And so work for New Shepard. All these programs take a bit. They're monster rockets for anybody who's listening. These are not easy things to design to. And even the small guys, I think, can tell you, launching stuff is a difficult, challenging, and as my old boss, John Eagle used to say, it's a binary business. Either you put the satellite where it needs to go or you don't. There's not a lot of ambiguity in launch. So it's a challenging thing. And typically when you talk about building something that is human rated, human capable, this is a different design challenge altogether, right? When you watch something fly with a spacecraft on top, yeah, you're nervous, right? There's a high nervous pucker factor, as we say. When you're watching human beings fly, you get a lump in your throat. Your stomach starts to turn into knots. It's something different when people are on top of the vehicle, right? So yeah, it's an extraordinary thing, and making it safe and affordable is really the point here. So yeah, I'm rooting for those guys. Fingers crossed they fly next year. We'll see. I'll probably have more to learn on that in the next few weeks as I talk to my old colleagues there. But I wish those guys well. Yeah.
You choose your words carefully, Clay, which I appreciate. So
it's all. I'm not trying to be coy about it at all. People say all the time, you fly when you're ready, right?
Yeah,
which is absolutely true, because it's not like one of these things where it's hundreds of millions of dollars worth of hardware at stake, right?
Yeah.
Now, if you talk about the entire pad, and you don't want to have a catastrophic event. This is super important stuff that can set you back. So engineers are going to try to drive down to every single, fault tree that they can to make sure that the thing's going to work and it's going to work properly. And you've got ground systems and launch systems are a complex system of systems, right? You've got guidance, navigation, control, propulsion, materials, electronics, all of this stuff has to work in concert. And at the end of the day, you need to be going, 9 kilometers a second to break Earth's gravity. I always tell people the story, like, you think about an Ariane 5 as a vehicle, it's about 780 metric tons sitting on the pad. By mass, right? 90% of that is fuel, either solid rocket fuel on the big boosters or liquid fuel in the main cryogenic tank. And then about 8% of it is the actual structure of the rocket, the metal, the hardware, the engines, all the systems that are on top. And less than 2% of it's the actual payload you're putting into space. That's the rocket equation right there in a nutshell. When you think about it by mass, right? It's like, just get like 1% into space. You need, 98 point something percent to actually break Earth's gravity. It's a hard equation. This is why staging and reusability, all these things come into play. And so when people think about launch, and it has become, there's so many launch startups now, but it is a challenging thing to do, and do it well and do it repeatedly, right? And so hats off to SpaceX and all these other companies that have launched and continue to launch, Rocket Lab and others that are launching successfully. It's a tremendously tough business to be in, but it's super exciting, right? You get up every day and you're launching rockets. It's nothing better than that. Well, maybe launching a space station, I think, is better than that.
No, there you go. And yeah, launching a rocket is no doubt successfully very, very difficult, and there's no question that the space station is not easy either. So we're looking forward to seeing Starlab fly. Clay, thanks so much for joining. Really appreciate it. For any of you guys listening, Clay is very friendly, so if you see him at a conference, definitely stop him and say hi. And I will see you, Clay, in Paris in 2 weeks.
Awesome. I'll see you there, Mo.
Right.
Thanks, man.
Thanks so much.
All right.
Okay.
Bye.